Hello, my name is Martin Ettenberg. I'm president of Princeton Infrared Technologies. Today I'm going to talk to you about shortwave infrared that we're doing at Princeton Infrared Technologies. So first I want to talk about our line scan camera, or our linear array imager. It's shown up here. This is a 1024 array on 12.5 micron pitch. Comes with square pixels for imaging, as well as tall pixels for spectroscopic work. Right now we're doing an imaging demonstration here, and we're looking at a lot of things. So our cameras actually see from 400 nanometers to 1700 nanometers. In this demonstration we're switching from white light, which you and I can see, to shortwave infrared light, which we can't see, which allows us to see some interesting features that you can't pick up with your eyes. In this case we have some fabric, coffee beans, rocks, water, and our logo. And when we look at them in the visible, which is in here, you can see our logo, the fabrics, the water. But when we switch to shortwave infrared, you can see things switch how they look. So in this case, the coffee beans and rocks in the white light is all kind of dark, hard to tell apart. But in the shortwave infrared, the coffee beans will stand out white and the rocks will still stay dark. Water becomes absorbing. It goes from clear to black in shortwave infrared. And so we're able to pick up water and water features like dryness of paper. We're able to look at fruits and vegetables. Lots of things show up because of water, because water's all around us, and we're able to detect that water. And so our line scan camera with USB output as well as camera link is able to do this at over 30,000 lines a second. And we do that kind of imaging. Our other product we're showing at this show is our 1280 by 1024 MV camera for machine vision. This is a single stage in-gas camera. This one goes from 400 to 1700 nanometers, 14-bit output, and does about 90 frames a second. We also have a version which we call the BP cam, which is a cooler version of the camera, and that actually allows you to go out to 2100 nanometers if you need to see longer wavelengths. We have a third camera, which we're not showing at the show, which is our scientific camera, which is a cooled camera, 4-stage TEC cooled camera, which allows you to take down the array down to minus 65 degrees C. The advantage of that is you can do very long integration times, up to 3 minutes, for very low light level applications. Let me show you what the camera actually images when it shows. So now we're looking at me in the 1280 by 1024 in the shortwave infrared. You can see my hair goes white. Skin color, we're looking, is looking at water absorption in my skin. And the biggest thing is, as I said, is water shows up. So you can see the water in this case is, acetone is black, and the water is dark. And so we could pick up water absorption, very similar to my skin. Glass is transparent in the shortwave infrared, so we can use glass optics. And so these cameras are used for detection of water. They're also used for seeing through silicon, solar cell inspection, and machine vision applications, mostly in agricultural inspection. We see a lot of applications, as well as plastic sorting and various other applications where you need to actually see the difference in various objects that are hard to differentiate in the visible. But in the shortwave infrared, you're able to pick up the differences because we're looking at a different wavelength band. And now we're also starting to see these imagers used in hyperspectral imaging. We're actually able to differentiate various chemicals from one another. We're happy to answer any of your questions. We have an application lab in our building, so if you have any samples you can't see or pick up the differences in the visible, please send them to us. We're always willing to take a look at them in the shortwave infrared and help you out. So thank you very much and have a good day.